Are you ready? On number 1, explain wave-particle duality for electromagnetic radiation. We have to explain how electromagnetic radiation is a wave and how it's a particle. Since I'm doing the video, I'm just going to go through it, okay? I'll go slow so that you can watch back and get it. Electromagnetic radiation is a wave from the double slit experiment. In the double slit experiment, light was sent through 2 slits, and on the back wall we see an interference pattern with bands of light and bands of darkness. Interference patterns are properties of waves, showing the destructive and constructive interference. Electromagnetic radiation is a particle due to the photoelectric effect. In the photoelectric effect, a source of electromagnetic radiation shined on a piece of metal would kick electrons off of that metal. Electrons are negatively charged subatomic particles. Particles interfere with particles, meaning that electromagnetic radiation has to also be a particle. Got me? If you get a question like this on the quiz, so if I ask you this question on the quiz, I don't expect it to be word for word what I just said to you, because truthfully, I ain't gonna remember word for word what I just said. It just has to hit those highlights. So interference pattern, double slit experiment, constructive destructive interference, photoelectric effect. Electrons are particles, which means that electromagnetic radiation has to be a particle. Now number 2 is one that's challenging, hard, and difficult, because we didn't write anything about it, but we discussed it. So explain wave-particle duality for electrons. What proves wave-particle duality for the electrons was in the double slit experiment. In the double slit experiment, electrons were fired through 2 slits. On the back wall, we see an interference pattern, which is a property of waves. Scientists placed a detector to observe the electrons. Once this was done and the experiment was ran again, we received 2 bands on the back. That is a property of particles. Whenever the detector was removed, you get the interference pattern. Detector present, you get the 2 bands, showing electrons are both waves and particles.
So you said double slit experiment showed an interference pattern, and scientists put a
Detector
detector in the room that the interference
by the 1 slit.
and that
It showed 2 bands, so like two bands. Instead of the interference pattern, it shows the 2 bands, and that's what you expect particles to act like. The interference pattern is the thing that was weird.
Well, so can you repeat why it's a particle?
Yeah, so electrons are particles because through the double slit experiment with the detector, it gave us the 2 bands, which is a property of particles.
what I said to put the detector in front of one side.
You can say that if you want to. That's fine. I know I already answered 3. That's interesting. Number 3 I already answered, but I want to go through this again so it's on the video for you. Okay? Explain how color works. You have a source of light, white, that is all colors combined. So that's what white is, it's all the colors combined. The white light goes and hits the object that has pigments in it. Those pigments absorb certain wavelengths of light. The wavelengths of light not absorbed are transmitted out, and those photons that are transmitted out goes to our eyes, binds to our proteins that send signals to our brain to tell us the color that we see. Number 4. Explain line emission spectrum and how they are collected / what they are.
Wait. It's for a project. Who
Okay.
you think's gonna win?
The game?
Yeah,
Be honest,
you gotta be honest. It's for a project from Miss Fields.
it's a frequency project.
I get that, but you come and act like, dude, it's like my team. Like, I'm going to Renegades. It's my team. I can't go against my team.
Hey, we got staff members saying we're gonna lose.
I'm sorry, but I mean, it's like, Pittsburgh Steelers. I'm playing the Kansas City Chiefs on Christmas, and I'm saying, go Steelers. Like, I mean, it's my team, man.
Thank you.
Huh?
Who do you like?
I'm sorry. What are your Eagles doing again? They ain't flying so high, are they, anymore?
What teams have y'all faced?
Are you kidding me?
And won.
Are you kidding me right now?
Name the best team that you beat.
I'm gonna pick this up afterwards, okay? And we'll have this conversation later.
Y'all beat each other.
Get this done.
We lost in our bye week. That's not bad.
Ridiculous. Okay, number 4. Explain line emission spectrum and how they are collected / what they are. Line emission spectrums are like fingerprints for elements, where energy is added to those elements, electrons are excited into the excited state, and they return to the ground state. When they return to the ground state, they have to give off energy, and they do this in the form of photons. Those photons are taken in, and those light sources are taken in, photons taken in. We break them apart through a prism that gives bands of certain wavelengths of light. Those bands correspond and represent certain elements. It's like a fingerprint for the element.
That's pretty good, huh?
You went a wee bit fast.
Okay, so if I just
Let's do
say,
it for the video.
line emission spectrum is a light taken from a source that has electrons. The electrons went from the ground state to the excited state. They gave off photons. Photons are broken apart to make a certain wavelength of light that carries a line emission spectrum that acts as a fingerprint for the element. The light is collected from electrons on the planet and broken apart so we can see the line emission spectrum, giving off evidence of light from the element's presence. Would that be good enough?
You're like really close, but you're missing a couple things. So like you said, it went from ground state to excited state, but you gotta talk about going from excited state to the ground state. Because when it goes from the excited state to the ground state, it's when it gives off the energy and we get those photons. And then, whenever we take that light in, we break it through a prism and it gives us the bands of certain wavelengths. Okay?
So, can you help me remember what it is?
Now you can talk about the Eagles.
On which one?